This is Linked Data Engineering, lecture number 6, Advanced Linked Database Applications. In the third part of the lecture, we want to talk about named entity resolution, which is an advanced linked database application. Okay, what did we do in the last section of the lecture? You remember that we did semantic annotation, and this often is based on semantic media analysis. So just imagine you have a text like this one. Neil Armstrong, the 38-year-old civilian commander, radios to Earth at the mission control room here, Houston Tranquility Base here, the Eagle has landed. And we have here Neil Armstrong, and if we hear the text and try to understand the text, of course we have a specific realization, something in mind that we associate with Neil Armstrong. Of course, this picture in the background helps that you associate here the astronaut Neil Armstrong, who was the first man on the moon in 1969. So Neil Armstrong in that case is much more than just a character string. And if you try to semantic annotate it, then of course you could do this with an entity of the knowledge base. And as a knowledge base we could use DBpedia. So for example, take Neil Armstrong here, annotate it with the Neil Armstrong entity from DBpedia. What does that help? So this up to now is simply a URI. So it's http dbpedia.org/resource/Neil Armstrong. But in the context of the knowledge base, you will get much more information about Neil Armstrong. You will see that Neil Armstrong is of type astronaut, and an astronaut is a subclass of person. Moreover, you will find out that the name of this entity is Neil Armstrong in English, and you will find out that its birth date is 1930 and it's August 5. And moreover, you will also see that there are relations to other entities. For example, that Neil Armstrong was one of the crew members of Apollo 11, and Apollo 11 had a crew size of 3, and Apollo 11 was a space mission, and so on and so on. So this is the way, for example, how you can explore and find out what Neil Armstrong really means. You understand something in the way that you put it in relation to other things of your knowledge. So if we associate a character string in a text with an entity from the knowledge base, we will put the entire knowledge in the knowledge base that is related to exactly that entity in context to this text, and then can better understand the text. So at least a machine then can do that, because this is a process that works similar like what is happening in our brain when we try to understand the meaning of a message here. Now, the point is, of course, I can do this annotation in a manual way. But on the other hand, there might be also automated procedures which help us to do this in a more convenient way, in a faster way, in an automated way. And this way, or this technique, usually is called named entity resolution. And you have to distinguish between named entity resolution and named entity recognition. Both are techniques which originally come from natural language processing, from NLP. Let's start with a, let's say, more general term, which is named entity recognition. What is named entity recognition? First of all, a named entity is anything of which it makes sense to speak of. Something, some concrete thing, some abstract thing, something I can directly speak of and I can give a name, I can name it. So for example, Neil Armstrong, I can name it with the name Neil Armstrong, therefore it's a named entity. Named entity recognition now is the process to locate and to classify atomic elements into predefined categories. So we do not make a link to a specific entity, we link a text fragment, for example, to a specific category and say this identifier, this character string refers to a person, this refers to a place, this refers to an event, and so on and so on. So if you map only these predefined classes, these rather generic or general classes, this is called named entity recognition. And in NLP, of course, this helps in the first place to understand the sentence. If you do a more detailed analysis, you want to know exactly not only that this is a person, this character string, you also want to know what person exactly is referred to with that character string. And if this person is an entity in your knowledge base, the more the better. Then you do so-called entity resolution. There you identify and link or group different manifestations of the same real-world object. And this is also then usually referred to as disambiguation, record linkage, object identification, because in the text, of course, Neil Armstrong will not always be referred as, quote, Neil Armstrong. He will sometimes be referred to as simply Armstrong or referred to as the first man on the moon. And simply then, of course, this also denotes the same entity, and therefore entity resolution should work in the way that the character string, which represents exactly this entity, should be annotated with that entity, and in an automated way you do named entity resolution. This is the process we want to dive deeper in this part of the lecture. The only problem here is, so what if there is no trivial unique identification? So for example, if this part of the picture is simply annotated with a string which says Armstrong, which Armstrong should it be? I mean, we see the picture, we understand the picture. If the machine only sees the text Armstrong, the machine has no idea which entity to choose, because there might be several entities which have Armstrong in their name. You can do the simple experiment. Go to Google image search or to another image search of one of the major search engine companies and search for Armstrong and look at the pictures in the result. Like here, you will find different people. You will find, of course, Neil Armstrong, but you will also see the man in the yellow shirt here, that's Lance Armstrong. And you will also see here in black and white photographs the man with the trumpet. That's Louis Armstrong. So Armstrong can stand for multiple things. And the point is to find out which is meant. This disambiguation process of this ambiguous information is also part of the named entity resolution or named entity linking process. If you are looking for Neil Armstrong, disambiguation can work also the following way. You can put a context term additionally to your search. For example, if you put Armstrong in the context of moon, statistically the probability that pictures of Lance Armstrong will be returned might be rather low. And of course, the probability that pictures of Neil Armstrong will be returned is rather high. And in this sense, context information helps us to understand information, to disambiguate information. So understanding, because of the ambiguity of natural language, requires context. In different context, the meaning of a conveyed message might change. So therefore, we need context. The more context we have, the more easier for us is it to uniquely understand it. You might remember exactly this semiotic triangle that we have spoken about in one of the first lectures. So if you hear or see the symbol Armstrong, usually this stands for a specific object, but you have no idea if it's an ambiguous term for which object it stands. Does it stand for Neil Armstrong, for Lance Armstrong, or for Louis Armstrong? In the end, it symbolizes a concept, and only in a given context you can make out which one is the correct entity you are talking about. So this process then to determine the one that is correct according to the context is called disambiguation. Okay, first of all we want to look at the concept of the process. First of all we want to look at the process of named entity resolution, and we do this in a rather simplified example. Let's consider we have the following text: Armstrong landed the Eagle on the moon. So to recapitulate this for ourselves, Armstrong here in that context means Neil Armstrong. And what does the Eagle mean? Any idea? The Eagle was the name of the lunar orbiter which landed on the moon. And the moon here, of course, is this celestial body. Of course, the satellite of Earth is Moon. How does named entity resolution work? First of all, we have to find out with the help of, for example, of natural language processing techniques, what are the named entities in the text. So what are the things which represent names? You do this usually by linguistic analysis with the so-called POS tagger, part of speech tagger, and then you are looking for the nouns, for example. And here the nouns would be Armstrong, Eagle, and Moon. And of course, then you do several other linguistic techniques, for example, normalization. Then if you have a plural form, you can lead it back to its normalized singular form. You have to look at different encodings and spellings. You have to take into account special language dependent characters sometimes. You have to think about abbreviations, about acronyms, about type dependent spellings, alternative names, synonyms. Fuzzy string mapping has to be applied. For example, if there are errors, of course, you can have a typo and stuff like that. So to determine all possible candidates in a knowledge base would mean you have to look at all the labels, the name tags of all your entities, and all of them who contain or consist of something which is labeled Armstrong would be, in the end, a possible candidate in your disambiguation and named entity resolution process. So here, for example, for Armstrong, if we look in DBpedia, we might find, of course, Neil Armstrong, but also Armstrong, Ontario, which seems to be a populated place in Canada, or Armstrong, Florida, Armstrong County, Texas, the Armstrong Tunnel, the Armstrongs, Armstrong, a moon crater, Armstrong, a car, or the Armstrong Twins, probably a band. So you see there are lots of possibilities for that. Okay, and in the end you have to do this in your sentence, which in our simplified example determines the entire context. So we look at the entire text to understand the single entities. We have to look for all the candidates of the named entities we have identified. And therefore, we might find for Armstrong 448 entities, for Eagle 95 entities, and for the Moon 156. And now you can determine each combination is possible of 3 out of them. Each combination is possible. But you have to find the one which is most likely. How do you do that? Usually you have several strategies. You can go via so-called popularity-based strategies. So which is the most popular entity which is most used? So for this you must have usage information. Usually if you have large text corpora, that's for example if you gather news articles over the decade, you might see which entity is or probably referred to most times with a character string. Or there are linguistic strategies, there are many strategies which are based on statistical properties, and there are also semantic-based strategies. A few of them we will talk about also in the subsequent lecture. And usually what you are using to determine exactly these strategies is you are using so-called reference corpora. You can use a reference text corpus. In our sense, this could be Wikipedia, so there are many Wikipedia texts and they are available online. Or you can use the link graph. So this is the links between all the Wikipedia articles. That's a link graph, also can be used for statistical strategies. Or you take the semantic graph, which is induced by the RDF graph of DBpedia. And then usually you make an assumption. So for example, you say, yeah, it must be Lance Armstrong, it must be Eagle the bird, it must be Moon, the celestial body, and then you simply look how your strategy supports or contradicts this assumption, and then you make a decision according to logical or probabilistic rules and constraints that you have. We will come back to that later on. Let's have a short look on named entity resolution in exactly our example. So Armstrong, Eagle, Moon, what could they mean? So for example, Armstrong could mean Louis Armstrong, Eagle could mean Eagle the bird, and Moon could stand for a song which actually was played by Louis Armstrong, which is Fly Me to the Moon. So this might be. But on the other hand, this might also be rather likely that Armstrong stands for Neil Armstrong, Eagle stands for the Apollo lunar module, and Moon stands for the celestial body, for the Earth's satellite. So what you can do, what is a simple statistical solution for that, is simply look in all of these Wikipedia article texts how often Neil Armstrong, for example, is referred to in the Apollo lunar module, or how often Neil Armstrong is referred to in the article of the Moon. And compare this to how often Lance Armstrong is mentioned in exactly these articles in Apollo lunar module and in Moon. I bet that Neil Armstrong occurs more often. And then do the same with the possible candidates for Eagle. Look how often Eagle the bird appears in the Neil Armstrong article and how often Eagle the lunar lander appears in the article of Neil Armstrong. And then do this with the Moon. So you see, you can statistically find out what is the most likely solution. And this would be one strategy for entity disambiguation. Another strategy would be look at the Wikipedia link graph, which articles are linked with each other. So you could find, for example, let's first look at the green links here, that Armstrong the moon crater somehow is linked to the moon, of course, and also Eagle the moon crater is linked to the moon. While you might also find that Louis Armstrong might be linked to Fly Me to the Moon, the song. But nevertheless, you will also find that Neil Armstrong is linked to the Eagle Lunar Lander module, is linked to the Moon, the celestial body, which again is linked to Neil Armstrong. Now, what you can do here is simple graph algorithm, look for strongly connected components, and if you find a strongly connected component among your candidates that we have listed here, then it's rather likely that this might be a probable solution to your disambiguation problem. And the other connections that you find, if there are missing links, so it's not a, let's say, a strongly connected component, but only a partial component or only a connected component, then this is even less likely. And if it's not connected at all, then the probability is even lower. So this could be, for example, another strategy to solve this named entity resolution process. In the next part of the lecture, we will look at exactly this process in more detail.